Miss Wiles, and in this video we'll be talking about linear functions. It's kind of an introductory video, but we'll cover a lot of things. A linear function, just by the word line, if you were to look at it in a graph, it looks like a line. It's some kind of line on the coordinate grid. Be vertical, be horizontal. It can, it's a line. It's not rocket science, it's a line. Now, there are some things you can tell about the line based on what it looks like. If it looks like A, if it looks like this, what we can tell about this is that it has a positive slope. So that's one thing we can tell. If it were actually on a coordinate grid, then we'd be able to tell something else, and we'll talk about that. If you look at B, this has a negative slope. Now, how you're going to remember that, I don't know, but the way I remember it is I think about if I'm reading from left to right, just like I read a word or a passage or something, if I read this line in A, it is going up. It's going uphill, and that tells me it's a positive slope. It's going to be harder to get up. If I'm reading from left to right in B, this line is going down, which indicates a negative slope. If I look at this one, which I would like it to be a little more vertical than that, this is a vertical line, straight up and down. Vertical line has no slope. And what I like to think about that is like if I look at A and I'm running and I come up to a hill, I'm going to have to go up, and it's going to take a lot more work for me to get up the hill. If I look at B, I'm going down the hill. I'm going to catch my breath and run downhill. If I look at C, unless I've got a lot more skills than I had yesterday, I'm not going to be able to get up that slope. So there's no slope. It's undefined. But here in D, we have a horizontal line, and it has a zero slope. There is a difference between the zero slope and the no slope, and the difference is the exact opposite. One of them's vertical and one of them's horizontal. Okay, next, we don't always have a graph, but we'll have an equation. And to be able to say that an equation is a linear function, we want to look for x, and we want to have a y. We wouldn't, if it was x squared, it wouldn't be linear. We should be thinking quadratic. If it was x cubed, it wouldn't be linear. That would be a cubic function. We're looking for x with no visible exponent. It would have a 1 if I really wanted to put an exponent there, but it doesn't have a visible exponent. And if we were to rearrange all the terms in it, in the equation, it'd be y equals something x plus or minus something. Now, this is called the slope-intercept form. If you can get a linear equation in this format, you can tell two things just by looking. Well, three things, really. You can tell that it's linear because of the x and no exponent with it. You can tell what the slope is just by looking for this value. Whatever the value of the coefficient of x is, that's the slope. Now, some other words for slope are like the rate of change. And how much is y changing every time that we look at it? And we can tell what the intercept is. Now, this is a little bit, there's two kinds of intercepts. There's a y-intercept and an x-intercept. This particular intercept is the y-intercept. The y-intercept is that point on the y-axis where the graph of the line or any kind of graph crosses the y-axis. So, for example, if we had a function or an equation that was y equals 2x minus 1. We have y equals 2x minus 1. Just by looking at that, with the x, I can tell that it's linear. With the negative 1, I can tell that it's going to cross the y-axis at negative 1. And not only that, I can tell that the slope is 2. Now, the slope being 2 tells me how the next number is going to look, how the next point on the line that I really can draw, and all I need is 2 points to be able to draw it, what it does. Now, slope is also rise over run. You've probably heard that before, that it's rise over run. So rise would be up or down, and run would be right. I always like to say that it's right. Because if we keep the same direction, we're reading the equation just like we would a word, that we're reading from left to right. So if my slope is 2, that means that to fit into this format of this rise over run, that it would have to be 2 over 1. Because it has to have a numerator and it has to have a denominator. It has to have a rise over a run, unless it's one of those vertical lines where it just goes straight up and down. So the rise would be 2. So I would come over to this point where I've plotted my -1 y-intercept, and I would go up 1, 2, and then I would go to the right 1. I go up 2, over 1. Here's my other point. I connect the dots, and that's what the graph looks like. So it all depends on what information I have. If I have y equals -1/2 x plus 7, then you should be able to look at this and tell that, number one, it's linear because of the x and the y. And there's no exponent with that. You should be able to tell what the slope is. So I want you to think of what the slope is right now. And now check yourself and see if you thought the slope was -1/2. Just by looking at that, you should know that this line, whenever we graph it, is going to go down because the slope is negative. So it's going to be shaped like that. And we should be able to tell one more thing. What is the y-intercept? Think about what the y-intercept would be. And you are correct. The y-intercept is 7. Now, that 7 doesn't mean anything unless you put it on the right spot on a graph. The y-intercept is 7. The y-intercept happens when x is 0. So if I were to give it coordinates, like I want to plot it on the coordinate plane, it's going to be 0, 7. That's what I'm going to plot. So I've got my x-axis and my y-axis. The y-intercept is 7, so I'm going to put a point up here on the 7. The slope is -1/2, so that means go down 1 and right 2. So from that point, from that 0, 7, I'm going to go down 1 and right 2, and I'm going to end up at 2, 6. Because when I went down 1, I went from 7 to 6 in the y. And when I went right 2, I went from 0 to 2. So make that connection, because then that leads into how can I find the slope if I have these 2 points? How can I find the slope if I'm looking at a graph? How can I find the slope if I have an equation? And those are the things that you need to be able to do with slope and linear functions. So here's an example of a graph. We have some x values and some y values. We don't have an equation, and we're asked to find the slope. Now, if you recall how we graphed the line in the first place, we had a rise over a run. So what we can do with this is we can look at 2 points on this graph. Pick any 2 points that you can actually identify. Would you pick this point? No, because you can't really tell what that point is at all. So you have to be very strategic about the points that you look at. So I'd pick this point because that point's great. It's at 0, 60. And I wouldn't pick that point because that's not where I can tell exactly what it is, but this one is. So I'd pick this point, and this point is 10, 80. Now, if I remember the concept of what slope is, it's the rise over the run. And you might also see this, especially if you look at like a super math book where everybody wants to look really smart, you'll see something that looks like this. And all that means is the same thing that you see there with rise over run. It's the change in y over the change in x. So we look at how did y change? It changed from 60 to 80. So how much did it change? It changed by 20, positive 20. It went up from 60 to 80. And then the run is how much did x change? From 0 to 10, it changed by 10. Now, am I going to say that my slope is 20 over 10? I'm always going to simplify things. And if I simplify that, my slope is 2. Will your calculator help you do those little calculations? Sure it will. Will it help you reduce things and things like that? Of course it will. So that's how we would find the slope if we have a graph. We'd actually pick 2 points and go from there, whatever it is that we want to look at. But we can also, if we didn't even have a picture to look at, we didn't even have a graph, and all we have is 2 points. We have 2 points. We have a line that goes through point 7, 18, and point -9, 20. It goes through those 2 points. And you can spend a lot of time doing this, but if you remember what slope is, if we're looking for the slope, the one that I like to remember the most is not rise over run. It's the change in y over the change in x. That one means the most to everything. It doesn't matter if you have a graph. It doesn't matter if you have 2 points. It doesn't matter what you have. The change in y over the change in x. And you might hear this called delta y over delta x. And it just means change. How much did y change? Is there a formula? Sure, there's a formula. But that's exactly what the formula says. The formula would say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But that means the same thing. Change in y over change in x. So how much did y change in this particular example from 18 to 20? How much did it change? It went up 2. Now you could put 18 minus 20 or 20 minus 18 in your handy dandy calculator. You'll get -2 up here. You'll get 2 here. It's all going to work out the same in the end. If I go 18 minus 20, my change in x, it goes from 7 to -9. How much change is that? It's going from 7 all the way back to -9. If I did 18 minus 20, it's going to be 7 minus -9, and that's going to give me the 16. And it changed by 16. It went down by 16. It changed that way. If I do this one, it's -9 minus 7, and that's -16. What happens when I simplify -2 over 16? I get -1/8. What happens when I simplify 2 over 16? Or 2 over -16? I get -1/8. You just have to be as crazy OCD as I am, and some of y'all know how I am. Everything is organized. If you go 18 first, you'll go 22nd for the change in y. And then you'd go 7 minus -9. It just depends on how you want to do it. Doesn't matter which way. If it was graphed, you're basically doing the same thing to work. I want to end with what I think is the easiest way. If you have an equation, then you don't have to work hard. It is what it is, and if you know what you're looking at, you can tell what the slope is. What is the slope of this equation, of this line?
4.
The slope is 4. Now, we don't want to make, is anything ever always easy? No. So then things get switched around, and you have something like y plus 9 equals 3x. Can you tell by looking at that what the slope is? It's 3. The only reason that you can tell that for sure is that y is on this side and it doesn't have a coefficient, and 3x is on this side and it's okay, so the slope is 3. As soon as things start changing around, you got to be careful though, because I could make it something like 2y plus 9 equals 3x. Is the slope 3 there? No, because the y has a 2, and it can't have a 2. It has to be a y by itself. So I would divide that by 2, divide that by 2, and my slope is 3 over 2. Does the 9 matter when we talk about slope? No. That number doesn't matter at all when we talk about slope. That number is the y-intercept. And if I know that about the equations, then I can tell some things just by looking real quick. We'll talk about the y-intercept, but not in this video. This video is all about slope and linear functions, and that's all I have to say about that.